Hi everyone. So in this video we're going to talk about properties of electrical charges. So you might ask, what are the properties of electrical charges? We'll go over 4 properties in this video and we'll start with the first one. So what does it mean when an object is electrically charged and when it's not electrically charged? So let's say we have a bar, and let's say that this bar is not electrically charged. All that means is that the total charge, the total positive charge on this bar plus the total negative charge on this bar is equal to 0. So that is what it means when an object is not electrically charged. Now let's look at what it means when an object is electrically charged. So let's say we have a cloth, and let's say we rub this cloth on this bar. And let's assume, based on the material properties of these two objects, when these two objects are rubbed against each other, the electrons on the bar transfer over into the cloth. So now we have this new situation with the bar that has now a total net charge that is positive and a cloth that has a total net charge that is negative. So these two objects are now considered electrically charged. So this leads us into our next property, is that if you have positive charge and negative charge and they're at a distance, and you start bringing them close to each other, they are going to, as they become closer together, they are going to attract each other. However, if you bring a positive charge and a positive charge from a distance, as you bring them closer together, they will repel each other. And this same observation also occurs when you bring two negative charges together. They will also repel each other. So the second property we're going to look at, we're going to talk about, is that opposites attract and the same repels. So now we're going to move on to our next property, and the property is stated as follows. Electric charge is always conserved in an isolated system. So what does that mean? If you go back to our previous example here, if you consider the bar and the cloth as an isolated system, we know that both of them originally had we know that individually each of them had a net charge of 0. So when they interact like this, and if we're still considering them an isolated system just because the isolated system is just these two objects, in both situations the net charge of this system is 0. So all this third property means is that electric charge cannot be created or destroyed. It has an analogous behavior to the conservation of mass and the conservation of energy. And so that is what it means. And so this property can be used to solve physics problems. So let's go on to the final property we're going to talk about. And this property is stated as follows. Electric charge is quantized. Well, you might ask, solve, what does that mean? So all that means is that let's say we have, let's say we have a box, and the box has a total net negative charge. So the total net negative charge of this box is going to be equal to n, which is an integer. It could be 1, 2, 10, 100, 1,000. You get the idea. And it's going to be the total net charge of this box is going to be equal to an integer n times the charge that exists in one electron. So all that means, or another way to kind of look at this property, is saying that you cannot have a charge amount that is smaller than an electron, than the amount of charge on an electron. So it's like saying the electron is the smallest building block of a total net charge on an object that is negatively charged. So you can think of it like that. So that is the fourth property we're going to discuss. And I guess just some observations that I want to leave with. One last observation is that the magnitude of the total charge of a proton is equal to the magnitude of the total charge of an electron. So let's review all the properties we talked about. So we discussed what it means for an object to be electrically charged, and what it means for an object to not be electrically charged, and what it means for an object to be electrically charged. We talked about the repulsive and attractive forces of charges. We discussed how electric charge is conserved in an isolated system, which just basically means electric charge cannot be created or destroyed. We talked about how electric charge is quantized. So that's it for this video, guys. If you guys like what you see, subscribe to this channel and like this video. If you have any questions or requests, leave them in the comments section below. This is Saul. Keep learning, everyone.